Okay, welcome to ACT Prep Day 27. You all should have your yellow sheets, day 27. So you want to go on ahead and pause the video so that you can work on the bell ringer, and pause the video, come back in about 5 to 10 minutes, and we will check your answers. Okay, so our bell ringer activity is on matrices, and you should remember this from about a week ago. You cannot add matrices that are not the same size. So if we look at the first one, it's rows by column. So this is a 2 by 3 plus a 2 by 3. They are the same size, so we can add them. And you just go through here and add corresponding numbers. 1 plus 3. 5 plus 4, and you can see here 1 plus 3 is 4, 5 plus 4 is 9, 3 plus 1 is 4, and so forth. They're both 2 by 3, so the result will be a 2 by 3. The second one, all you are doing is taking that constant, that 3, and you're multiplying each one of these terms in here by 3. So 3 times 2 is 6, 3 times 1 is 3, 3 times 5 is 15, and you just follow that pattern. Now on this one, multiplication is a little bit more difficult. Okay, this is a 2 by 2, and this is a 2 by 1. And remember, it's like dominoes. These two middle ones must match, and when they do, the resulting matrix are the two bookends. So the resulting matrix should be a 2 by 1, as you see here. And this is the one that's difficult to remember. I really struggle to remember it. And again, a TI-84 calculator will do this for you. You literally key the matrices in, and then you say, multiply the first one times the second one. And it's a no-brainer. And when you get to Algebra 2, I'm telling you, I know they're $100. I know, and I know $100 is not cheap. But if you think about all the times it saved you, if you give $1 every time it made your math homework easier, trust me, you'd probably spend $500. It's worth the money. So for the first one, for this first number 18 here, you do 3 times 4 plus 1 times 6. And you end up getting 12 plus 6, which is 18. For the 26, it's 2 times 4. 2 times 4 plus the second term's 3 times 6. So now we get 8 plus 18, which is 26. For the determinant, you should remember it is A times D minus B times C. I always think of cross multiplication. 3 times 5, 15, minus 2 times 3, which is 6. Excuse me, and that gives us 9. Hopefully everybody got 100, yay. So today we're talking about, excuse me, allergies, inequalities, graphs of inequalities, and circles. I will say this, and I've not used it, I've heard this from students, that if you have a TI-84, the older version, the black and white version, it does not shade on inequalities, but the colored versions do. So if you struggle with graphing inequalities, that might help so that you know which side to shade. So when we do inequalities, this is where the two expressions are not equal. We're just trying to get an idea. Kind of like if I lined you all up by height, I would be using an inequality. Well, you're taller than her, but I'm not measuring how much taller. I just know you're taller. And that happens a lot of times. So we have our 4 expressions. We have less than, greater than, less than or equal, greater than or equal. Now, if we look at a number line, okay, sometimes that helps. So if we have x minus 3 is less than or equal to 6, we can graph this on a number line, and you treat this just like it's an equation. If we add 3 to the left, we have to add 3 to the right. And that's where we get x is less than or equal to 9. Since it's equal to, that's a closed circle here. If it was just less than, that's where you do the open circle to say don't include 9. And then we draw it to the left because we want less than. Now, some teachers teach students that if you look at the order of operation, since this is pointing to the left, that's the way your graph goes. That's a yes and a no. Because some students do that all the time and they get the answer wrong. This is only true when x, your variable, is on the left. Because if this was rewritten as 9 is greater than or equal to x, and you use that theory, it would tell you to point it this way, which is incorrect. So if you use that method, ooh, this is pointing to the left, I draw my line to the left, you have to make sure your variable is on the left, or it doesn't work. Little tidbit there. Things to remember. If you multiply or divide by a negative number, you have to flip the inequality sign. This is the only difference that there is between it being an equal sign and an inequality. So if you have a number, here we've got 2x, negative 2x is greater than 4, that would tell us we're going to divide both sides by a negative 2. So we are multiplying or dividing by a negative. So we have to flip the inequality. Have to flip it. So instead of it being greater than, it's now got to be less than. And it's just a rule you have to remember. Okay. Now, when we graph an inequality, okay, on a number line, if it is greater than or equal to, less than or equal to, we have to use a closed circle. If it's just less than or greater than, we use an open circle because that says do not include that number that I've circled. So here we've got x is greater than 0. There's no equal sign. We used an open circle. Here is x is greater than or equal to 0, and we used a closed circle. Now I'm going to give you a little bit of tidbit. Some professors in college, I see this in college more than I do high school, but it is trickling down into high school. They are no longer using, they don't use the circles because sometimes it's hard to see. You get a kid that goes, is that closed? Is it open? Or sorry, I've had those. And they go, oh, it was open. Well, it looks closed to me. They are using parentheses and brackets. So an open circle would be the same as a parentheses. And a closed circle, that's terrible, sorry, would be brackets. So you might see this equation written as parentheses and then to the left. This one you might see written as a bracket and to the left. That tells me that it is less than or equal to, or greater than or equal to. This tells me, or this says it's greater than. This one tells me it's greater than or equal to. And you can see, it makes it a whole lot easier to decipher, is it a open circle, closed circle? Now, graphs of inequalities. When we graph it on a coordinate plane, you're going to have the x and y coordinate. So when it is supposed to be a closed circle, we use a solid line. So if it's here, these, less than or equal to, greater than equal, our line will be solid. But if it is less than or greater than, we're going to make the line dashed. That's like a closed circle and an open circle. Okay, so if we look here, here is the graph. We have y is greater than. This is the first thing I do. I go, oh, it's greater than. I have and I write it down. It's a dashed line. So I know once I'm ready to graph that line, I've got to dash it. Okay, now, once you have the line, you're going to choose a test point. This is probably where students make the biggest mistake. How do I know which side to shade on? Well, you want to choose a test point. And again, work smarter, not harder. I always choose 0, 0. The only time I don't choose 0, 0 is if the line actually goes through 0, 0. Then you can't use it. And I look, 1, 1 is my next one, or 1, negative 1, negative 1, negative 1. I try to find something that the line's not going through that's the easiest numbers to work with. So this one does not go through the origin, so I'm going to use it. I'm going to test this point right here, 0, 0, and see. It's not on the pen. I'm going to test this point. And if this point works in the equation, I shade the side it's on. If it fails in the equation, I shade the other side. Well, how do I test it? Well, this point is going to be 0, 0. So x is 0, y is 0. And I just plug those numbers into this equation. So I'm going to get, 0 is less than, what is 2 times 0? 0 minus 2. Sorry, greater than. I think I said less than. So is 0 greater than negative 2? Yes, it is. It's true. So I'm going to shade the side that includes 0, 0. If it came back false, then I would shade the opposite side. Again, I've heard that TI-84 Color Edition will shade it for you. We'll graph it and shade it for you. A circle, this is a curve that always has the same distance from the center, the radius. This is probably the biggest thing here. And most of you have probably not seen this yet. This is probably new, but you will see it in geometry, and it is on the EOC. So you can get a jump on that section right here by studying this. The equation of a circle is always x minus h squared plus y minus k squared equals the radius squared. Now you're probably going, okay, I get x, I get y, but what's this h and k? Okay. H comma k is the center of the circle. It's the actual x and y coordinate of the circle. But we have to have an x in the equation, this is always there, and a y in the equation. Okay, those are constants, they stay. But we can substitute in for the h and the k as well as the radius. And if you know the formula, it makes it really, really easy. So here, if they say the center of the circle is 0, 0, the radius is 2, write the equation in standard form. Here is standard form, the blue box that I have outlined. So what is x minus 0? Because if you go over here to the center, this is the h and the k. Here is h comma k. So x minus 0 is x. I don't need to include the 0. So that's x squared. That's where we get this. Y minus 0, that's our y value of our center, is just y. So that's y squared. And since our radius is 2, it's r squared. What's 2 times 2? That's 4. There's the equation of my circle. Again, it's super easy, but you have to memorize the equation. So this is probably one of those pages you want to bookmark and look back over before the ACT. All right, here's our ACT example. So I want you to hit pause and try it, and then get back with me when you think you have it. Okay, so let's look at this one. We've got y equals x squared plus 2. I know from graphing that this is a parabola. Why? Because it's x squared. You're going to get a lot more of that in Algebra 2. You should be able to know that this one is a linear equation, y equals x plus 4, so that's the blue one. So even by process of elimination, that makes the other one the red one. They want to know, okay, what values of x satisfy the equality that x plus 2, the red one, is less than x plus 4, the blue line. And you're probably going, I don't know how to do this math. Oh my gosh, I left it blank. No, I haven't been taught this yet. Think about it. Where is the red graph less than the blue graph? And it's right here. That's where the red line is less than the blue graph. And so they're wanting to know for what values of x. So you just look here. I think we're going 2, 4, 6, 8, 10. They're counting by twos. So this one's sitting at 1, and this one's sitting at x is 2. Oops, sorry, negative 1. So it's where x is greater. That's a less than, so we don't want that. X is greater than negative 1, but less than negative 2. Again, we just wanted to know where it was less, so what's below the graph? Okay, so 5 ACT questions. Set a timer on your phone, on something, and time yourself while you do these questions. Hit pause, and I'll see you back in about 5-6 minutes. Okay, welcome back. So the first one, here's one of those where it just says x and y are real numbers. What must be true? And my rule has always been pick a number. We want x to be greater than 0. Okay, x is greater than 0. Let's let x be equal to 1. Y is less than 0. Okay, let's let y be equal to negative 1. Sometimes using 1 doesn't work, might in this situation. So here we go, first one. What is 1 divided by negative 1? Negative 1. It is not greater than 0. The absolute value of 1 is 1 squared. So I get 1 is greater than, what's the absolute value of negative 1? Excuse me. It's not B. 1/2 minus 4, well, that gives me negative 3 1/2. I think in terms of money, $4 minus 50 cents. Then we have here, what is negative 1/2 minus 4? Well, that's going to give me negative 4 1/2. And negative 3 1/2 is greater than negative 4 1/2 if we look on the number line. So I'm kind of like, I think it might be this, but let me double check. 1 squared, 1 plus 3 gives me 4. Is that greater than negative 1 times negative 1 is 1 plus 4? Nope, it's not that one. And then here, 1 squared is 1. Is that greater than negative 1 squared? No, it's the same. Yes, my C was correct. So I can put a nice star. I've double checked. I'm good to go. Got this one right. Next one, which of the following is equivalent to the inequality? 2x minus 4 is equal to 4x plus 12. When you do this, treat this as an equal sign. Whatever you do to the left side, you have to do to the right side. The only different rule is if you divide or multiply by a negative number, you must flip the inequality. So let's get all of our x's on the same side. I like to keep my variables positive, so I will move them so they stay positive. And I end up getting negative 16 is greater than 2x. And the reason I like to keep it positive, especially on inequalities, is then I don't have to worry about forgetting to multiply or divide by a negative. Now I divide by 2 and I get x is less than negative 8. Now they don't like x on the right, so I just choose to rewrite it. X is less than negative 8. And my answer is there we go. Here, which one of the following inequalities is graphed in this coordinate plane? Well, first of all, I look, it's a solid line. I was hoping that would eliminate something, and it doesn't here. That really kind of stinks. Okay. So which one of these graphs is the line? Well, you can look and see we've got a slope here of 2, and we have a slope here of 1. So let's check it. Let's go look at the slope. They're counting by 2s. That's probably my biggest mistake, is I assume they're always counting by 1s. They're counting by 2s. But if we look at this, it goes up 2 and over 2. So what is 2 over 2? That has a slope of 1. It's not these two. Okay. I have a funny feeling it's this one, possibly, because it's 2 and 1's greater than or less than. So let's look. And let's try a point here. Okay. So we want one. I'm looking here going 0, 0 is included in this graph. So let's plug it in here. Is 0 greater than or equal to 0 plus 2? Nope. Is 0 less than or equal to 0 plus 2? Ooh, it could be that one. Is 0 less than or equal to 0 minus 2? No, 0 is greater than. It's not that one. Answer is D. Now, if you had a calculator, you could go through and try to graph each one, but that'd probably take you a lot more trouble. I figured out the slope, plugged in 0, 0 because it's one of the ones included on the shaded side, and it's not going to work in the ones that aren't the correct equation. Here we've got an equation of a circle below. They want to, or a graph of the circle, and they want to know which one's the equation. So you have to remember that formula, x minus h squared plus y minus k squared equals the radius squared. Well, the center here is obviously 0, 0. So that means it's going to be x minus 0 squared plus y minus 0 squared, or simply x squared plus y squared. And this is why doing problems over and over are good, because you memorize it. I instantly looked at this and went, it has to be D or E because the center's at 0, 0. Now I need to look and find out what my radius is. And it looks like my radius is 17. So it's not equals the radius, it's equals the radius squared. So it's 17 squared, which is E. And again, the trickiest part in this is knowing that circle formula. Okay, our next one, we've got a center of the circle lies on the x-axis and at x is -3. So you can almost go back up here. It's where x is -3. They're counting by, but it's on the x-axis. So this would be a coordinate of -3, 0, because it's on the x-axis. That's where y equals 0. So that's the center of the circle. If the circle is tangent to the y-axis, okay, it's tangent. This is where you have to know what tangent means. 1, 2, 3. So here's my center. If it's tangent to the y-axis, then that means that this circle is only going to connect to the y-axis at one point. Excuse me. So that's going to be here. If it's sitting here, it's going to be tangent at 0, 0. Why is that important? I can now calculate that the radius has a length of 3. That's what they're wanting me to figure out. So here's the center of my circle. I have a radius of 3. Let's write the equation. It's x minus whatever the x coordinate is, which is a -3. That's probably the biggest mistake students make. Plus y minus 0, we already know that's just going to be y, equals the radius squared. So this is going to become x plus 3 squared, because negative times a negative is a positive, plus y squared is equal to 9. So let's find it. And it looks like it's F. Hardest part here is the tangent part. And again, that's why you want to do practice problems, because once you see this and you're like, oh, that's all it is, it sticks in your memory and you memorize how to do it. But if you've never seen it before, you're looking at it going, I have no clue. All right, so now you've got the exit ticket. You've got to turn it in for a grade. If you were unsure, you need to ask me. I have students still refusing to ask for help. It's killing their grade. Ask me. I want you to learn the material, okay? I want to make sure that you learn it. So here we've got, it's a two-part. You have to sketch the circle correctly, And then you have to give me the equation of the circle. So that's 5 points each. Now, it doesn't have the grid lines, didn't come out really well. You can create your own grid lines, like do the little tick marks, you know, ooh, put it over here, label it so I know what it is. I'm not looking for an artist. I'm not looking for this amazing circle. Now, granted, if it looks like it's a squashed egg, yeah, I mean, come on. But I want it to be visually representative, be marked so that I can tell what your coordinates are, and just draw me a circle. It's got to be in the right plane. The center needs to be correct. The radius needs to be correct. And then give me the equation of the circle. Again, if you have a question, ask me. And have fun on day 26.